Question 7, Chapter 12 of the Edexcel Pure 1 book. Question 7, Chapter 12. So, given that y is equal to 3 times the square root of x minus 4 over the square root of x, and x is greater than that, greater than 0, find dy by dx. Okay, so let's just make this simple and say that 3x to the power of a half for the square root minus 4x to the minus a half. Okay, now we'll do dy by dx. We're going to have a half times 3, which is 3 over 2x minus, so a half minus 1, and then minus 4 multiplied by minus a half x, and we have minus a half minus 1. Okay, so tidy that up a little bit. We still have 3 over 2x, and that's minus a half. The minus 4 minus a half gives you plus 2x minus 3 over 2. If you wanted it out of the notation for the indices, we would have 3 over 2 the square root of x plus 2 times the square root of x cubed. Okay, or they might want to put the square root in the cube. It doesn't really make any difference. Okay, question 8 then. Question 8. A curve has an equation which is 12x to the half, okay, minus x to the 3 over 2. Show that dy by dx is equal to 3 over 2 x to the minus a half brackets 4 minus x. Okay, so to begin with, let's do the differentiation on the top one there, and we are going to get 12 over 2 x to the minus a half minus 3 over 2 x to the power of a half. Okay, what does that give us? That gives us a 6. 6 x to the minus a half minus 3 over 2 x to a half. How do we get the factorization of all of that to come out? Okay, that's 1.5. So if I take 1.5 out, there's 4 1.5s in here. Okay, so we need to take the whole thing out. Was that a half? Yeah, 3 over 2. Right. So I am going to basically take out of this, I'm going to write this as 4. Dividing 6 by 3 over 2. Okay. And taking the x minus a half out gives us the 4. 3 over 2 x to a half, but we're taking out a minus a half. Okay, so dividing it by that gives us the minus x. Okay, so what's just happened there? We have had minus 3 over 2 x to a half divided by 3 over 2 x to the minus a half. Okay, so the 3 over 2's have cancelled. Okay, leaving us a minus, which is good because we've got a minus. And we have ended up with minus x to a half take away minus a half. Minus and minus is a plus, so we've got a half plus a half, which of course is 1, which is why we've got minus x inside that bracket. Okay, that's showing it's there. Right then, that's part A. What was part B on this one? Was there part B? Yeah, find the coordinates of the point where the gradient is equal to 0. So we just need to put all of that equal to 0. 3 over 2x minus a half and 4 minus x. So we end up with x equals 0, taking the first bit of it out here, and we also end up with 4 minus x equals 0, showing that x equals 4 being the two coordinates. And so we need to put them back into the original equation so that we can find the y coordinates. So y equals, where's the original equation? 12 times 0 raised to the power of a half, which is just 0, minus x to the 3 over 2, and it shouldn't be x, it should be 0. Okay, which gives us 0, so y equals 0, giving us 0, 0 as our first coordinate, and on our other one we end up with y equals 12 times 4 to the power of a half plus minus 4 square rooted and then cubed 3 over 2. Okay, so we get 2 here, which gives us 24, and we get 2 here. 2 times 2 times 2 is 8 minus 8, and so we get 16, giving us 4, 16 as our other coordinate. Thinking about it, if we plot this out, it comes nowhere near as 0, 0, because this would divide through, and so that's not there. It's just x equals 4. So you can ignore that bit on the side. All right. Question 8. Question 9. Expand x 3 over 2 minus 1 and x minus a half plus 1. Well, that doesn't look nice, does it? Okay. Expand that. X times x. Have a quick think what happens here. If you have x squared times x cubed, you do x2 plus 3, giving you x to the 5. So on this one, when we do this, we're just going to have x 3 over 2 minus 1 half, i.e. adding the half. Okay, and then plus x 3 over 2 for the x 3 over 2 times 1. Then we're going to have minus x to the half, minus a half even, for the minus 1 times this, and minus 1 times plus 1 is minus 1. So that's 1.5, take away a half, so that's just x plus x to the power of 1.5 minus x to the power of minus a half minus 1. Now they want dy of dx of that if it was equal to y. Okay. So dy by dx is going to be 1 for the x term plus 3 over 2 x to the power of a half, because 3 over 2 minus 1 is a half, plus a half x to the minus 3 over 2. Okay, use your answer to part B to calculate the gradient of the curve at the point where x equals 4. Okay, x equals 4, so dy by dx is equal to 1 plus 3 over 2, 4 to the power of a half, plus a half, times 4, which is to the power of minus 3 over 2. Which is equal to 1 plus 6 over 2, because the 4 is square rooted to a 2, times the 3 is 6, 6 over 2, plus a half times, this is going to be 1 over the square root of 4, which is 2 cubed, which is 8, so a half times an eighth, so we get 1 plus 3, a half times an eighth is a 16th. Okay, should be a 3. Okay, so we end up with 4 and 1/16 as the gradient.